Welcome to the Genius Factory. Enjoy the video.
You begin by defining decision variables in a compact range. Name those cells if possible. Next, create the objective cell that references those decision variables so X cell can evaluate it. Then build constraint expressions as formulas in their own rows and keep right-hand side values in a separate column for clarity. Once done, convert the decision cells to named ranges to simplify solver inputs, and make sure your objective uses the exact same names for consistency. You now open Solver and point it at the objective cell, choosing maximize or minimize depending on your goal. Then set the changing variable cells to the decision variable range you prepared. This tells Solver what it can change. Add each constraint by selecting the formula cell, choosing the relation, and selecting the matching RHS cell for the limit. Make sure to pick simplex LP as the solving method for linear models. This ensures correct algorithm selection and faster results. You run Solver and observe the decision variable values and objective outcome to confirm they make sense. Once Solver finishes, request a sensitivity report to check dual values and reduced costs. This helps validate the linearity assumptions and reveals tight constraints. If Solver reports infeasible or unbounded, check for sign errors, omitted constraints, incorrect equality versus inequality types, or missing variable bounds. Finally, make incremental changes and rerun to isolate the issue.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.